So hello everyone and welcome to this Ask AuxEn Anything session. And as you all know, this is a weekly session that we conduct where we invite structural engineers to ask their doubts related to any steel or RCC design concept that they may be facing, or any construction site issues or topics related to a particular project that they are doing. So this is the 27th such session that we are conducting, and welcome all of you to this session. So, as we do always, we'll start with taking up the questions from the Google form. Then we will take up the questions from uh, any questions received on email, and then I'll take questions from the live chat. So, this is the first question that has been asked by engineer Rishabh Thakre, and he is from Mumbai and he's a working professional. So he's asking how to design and detail flare columns in RCC building. So we have answered this question couple of times earlier also. In earlier such sessions we have answered the question. So there are three ways in which you can do it. Modeling of flare columns. So flare columns, either you can use taper section option in ETABS. Tapered section option in ETABS you can use tapered section option, or if you want to model them as shell elements, you model them as shell element. So suppose this is your floor level and this is your floor level, and in between you want a flare column. So what you can do is you can construct this type of a whatever flare geometry you are proposing, you can make this in shell element. Okay, and the thickness of this shell element will be the width of the column, let's say. All right, so the thickness of this element will be the width of the column, and these dimensions you will get from the flared geometry. Okay, and then you will assign the peer labels to it. Once you assign the peer labels, then ETABS will give you the design results. If you are doing it as a tapered section, automatically ETABS will give you the design results. Third option can be that you put internal nodes. So you put some internal nodes, and then to each element in between those nodes, you assign to each element between the nodes, you assign a section property, a frame section property. Assign frame section property. So this can be a third way. That means between these floor 1 and let's say floor 0, you make a line element and have nodes inserted like this, and then to each piece or each portion you assign a section property, different section properties you assign, and the dimensions of those section properties should represent your flare column geometry. So this is how you can do it. So three options come to my mind if you want to do a flare column in ETABS. Okay, so this was engineer Rishabh Thakre, and he has put another question. As per, so I'll just take his question. This was regarding flare columns. This was his first question. Now I'm taking his second question. As per IS 1893 clause number 6.4.2, when to use design spectrum acceleration, when to use equivalent static, and when to use value for response spectrum. So I think he is asking when to use response spectrum method and when to use equivalent static. So that criteria, when to use equivalent static, that criteria is quite clearly given to you in IS 1893 part 1. So you can refer that criteria clearly given. Okay, So it will depend on the zone. I think up till zone 3, 15-meter height in zone 3, if I remember correctly. Although I think I'm not able to remember it correctly, but what I can, as per my memory, what I remember is up to 15 meters height in zone 3, you are allowed to go for equivalent static. Of course, your building should not have any vertical or horizontal irregularity, and your building should be up to 15 meters in zone 3. If that is the case, if I remember correctly, you are allowed to use equivalent static. Any structure in zone 4, 5, or structures which are having height more than 15 meters in zone 3, or structures having vertical horizontal irregularities, you are required to use response spectrum for it. So those criteria are quite clearly given in the 1893. So you read that, and if you are required to use the equivalent static, then you have to use the SA by G curve for equivalent static. If you are required to use response spectrum, then you will have to use that SA by G versus time period curve, which has the rising R. Of course, you don't have to do it. Software are smart enough to include that in their calculations. So when you assign response spectrum, uh, ETABS or STAT is smart enough to take the appropriate SA by G versus time period graph. Okay. All right. So this was Engineer Rishabh with his questions. Now I go to uh, Engineer Bala from Chennai. He is a working professional, and he has put his question over here. So let me just type it in the Google form. Sorry, let me just put it over here. So in his question is Engineer Bala from Chennai. He is a working professional. He is saying in model participation factor, but in some cases, this. So he's saying in model participation factors, first two mode transactional is a wrong word. Translational, Transla- not transactional, translational. So he's saying first two modes should be translational, third mode only in torsion. But in some cases, when we have large podiums in ground level, uh, you may get second modes in torsion, or second mode will be torsion like, but the total displacements along x and y and the average displacements are in control. Do we still consider this as torsionally irregular? No. So see, you have to use. I think this is the cause to many people. This is a cause of confusion for many practicing engineers. So there is nothing to be confused about. You just read the table 5 of IS 1893. It's quite clear what your code is asking you to ensure. Okay, I'll just paste the screenshot over here from table 5. Let me just paste a screenshot, and we shall see what's happening. So in my opinion, we have made this issue unnecessarily complicated, whereas it's not such a complicated issue. Okay, so I'll just paste this. Of course, this has been superseded by an amendment provision, so I'll paste that also. So this is the original clause 1893 table 5, and yes, I think you can see this. And then this has been superseded by amendment 1 to 2006 1893 part 1. So this last para has to be, this is the amendment clause that I'm showing you. So if you see torsion irregularity, are you able to see this on the screen? Hello, is this visible on the screen, please? Yeah. So torsion irregularity, if you see torsion irregularity, usually a well-proportioned building does not twist about its vertical axis. However, this statement is not entirely appropriate because your buildings may be well proportioned, but because of inherent geometrical issues, it still may have twisting effects about its vertical axis. Uh, a building is said to be torsionally irregular when. So this has to be okay. Yeah. So when it this has to be replaced by no, the last para has to be replaced by this para has to be replaced by this amendment. So a building is said to be torsionally irregular when the maximum horizontal displacement of any floor for earthquake loads at one end is more than 1.5 times its minimum horizontal displacement, and the natural period corresponding to fundamental torsional mode of oscillation is more. So either your first or second modes are not translational, and this criteria is not being met, then your building is said to be torsionally irregular. So what you need to do in such cases, in a building with torsional irregularity, you find out the average displacement and the minimum display sorry average displacement, and then you have to compare the maximum displacement and the average displacement, and then if it is more than in a building with when the horizontal total displacement at one end of building plan. So if you're 1.2 delta average and delta max, and if this lies between the maximum displacement lies between 1.2 to 1.4 times the average displacement, then your building is said to be no wait a minute. Yeah, so if your delta max is in between this range, then what you need to do, then you need to ensure that the first two modes are translational modes, and then you also need to perform a response spectrum analysis or any three-dimensional dynamic analysis. If that delta max goes above 1.4 times delta average, sorry, if yeah, then the structural configuration shall be revised. But suppose your delta max is less than 1.2 times delta average, then in my opinion, you need not do anything for it. Okay, you need not do anything for it. You may just perform the response spectrum analysis, and that should be sufficient for you. So even though your modes are torsional modes, first two modes are torsional modes, still if your delta max is less than 1.2 times delta average, I don't think there is cause of concern. You need to perform response spectrum analysis. Okay, and of course, if your delta max is in between 1.2 delta average and 1.4 delta average, then you have to ensure that your torsional modes are not the first two fundamental modes, and you also need to perform response spectrum analysis. If your delta max is exceeding 1.4 delta average, then you have to reconfigure your or replan your building. So as Mr. Bala is saying that in his case, total displacement are being met, those criterias are being met, that's what he's saying. So yeah, so then in such case I'm assuming that in for you the delta max is less than 1.2 delta average. If that is your case, then just perform response spectrum analysis, and that's it. Okay, see, for some shapes of the building, for some plans, it will be impossible for you to have the first two modes as translational modes. It will not be possible for you. So this is the way to do it. Okay. So code is quite clear. You just go through that table 5 criteria, and I think you will understand what needs to be done. Just hold on, I'll be back. Yeah, so this was Engineer Bala with his question. Let me just go to next question. And this question has been asked by Engineer Anukul Kumar. He is joining us from Delhi and he is a postgraduate student. So he has a couple of questions, three questions actually. So he's saying, we are designing the structure for MC level earthquake. However, I would like to understand the procedure to perform analysis and design for DB level in ETABS. No, you are wrong over here. We are not designing as per the current IS 1893 Part 1. We are not designing for MC level earthquake. We are designing for design basis earthquake. And when we do this Z upon 2 into I upon R into SA by G. So when we do this Z by 2, this is the DB level earthquake. Okay. So you procedure, you need not understand anything different from what is already given in the code, because as of now in the code we are designing for the design basis earthquake. Okay. Yeah. And in the upcoming code, I think they have now, instead of design basis earthquake, they have now gone ahead with a MC level earthquake. So they have just revised the return periods accordingly. They have revised the zone factors, or they have revised the level of earthquake to MCE. So the procedure still remains the same. Procedure still remains the same, but what has been adjusted, because now we are considering for higher level earthquakes, the load combination factors will be revised now. Okay. So for example, I don't remember it completely, but now earthquake, let's say, in a load combination where we combine dead and live, earthquake will have a factor 1. Why? Because now it's not a DB level earthquake, it's a MC level earthquake. So I may be wrong with this combination factors that I mentioned, but understand the principle behind it, that in the upcoming revision of 1893, you will see the load combination factors of earthquake being revised. Okay. Yeah. So this was his question. Next question is, I have shared an image over WhatsApp. Correct height to be considered for fundamental time period calculation. Okay. So let me just open WhatsApp and bring his image over here. Uh, he has shared it in the form of document. I don't know. Just hold on. I am just bringing the image that he has shared on WhatsApp. Mm, what to do? Yeah. So this is his first image that he has shared, and another image he has shared. Okay, so his question is, I hope the images are visible. His question is, based on the marked section, I would like to confirm the correct height to be considered for fundamental time period calculation. Yeah. So see, the understand a simple logic over here, that when you want to calculate the time period, uh, would you like to have higher time periods or would you like to have lower time periods, which are going to be more critical in your calculations? If you wanted to calculate the horizontal seismic coefficient AH, which time period will give you a more critical uh, AH value, higher time periods or lower time periods? So any structure which any calculation where you will get lower time periods will give you more critical time period, will give you more critical AH, isn't it? So when you are calculating AH from SA by G, you would ideally want T should be as low as possible so that you get the maximum possible SA by G. So that's why what your code is telling you, that when you have got a sloped building like this is his building that he has stepped something like this. Instead of taking this height h2, you take the smaller height h1. Smaller height h1 means time period will be smaller, which would mean that you are getting a more critical SA by G and more critical AH value. So while calculating time period, this is the concept that you should use. Take height as low as possible. But now when you are going to put it in the story range, what ETABS does is that when you put it in the story range, what happens, that it applies, so it will calculate the earthquake forces, and while application of story shears, it will apply them only between the floors that you have specified. You understand? So for example, if you give the bottom story as base 1, let's say, if you give the bottom story as base 1, and if you give the top story as this whatever roof, then what will happen, that it will calculate the earthquake forces, and then while distributing it to story levels, it will only apply the story level forces on these floors. Do you understand? So it's going to basically miss out on the, it's going to miss out on these floors. This will affect your, this will affect your overturning moment calculations. See, it will not affect your base shears, because base shears is finally just the summation of total shear force. So however, it may not affect your base shears, it may affect your overturning moment calculations. So my suggestion to you would be that you give the program calculated time period. Okay, you give the program calculated time period, and then the story level you give it from the bottom. Sorry, not program calculated, you give this to user defined time period as you have done. Okay, so in this you do your whatever formula is applicable to you. In this h height you take this smaller height, so that you get a more critical time period, and then while defining the bottom story, take this base 2 as your bottom story. Clear? So in this manner, it will get applied to different floor levels also. And because you have given your own custom height, you will get the time period that you want, which will be the critical time period. So this is what you can do. Okay. Then Mr. Anukul is asking that as per 1893 Part 1 2016, the number of modes considered in analysis should capture at least 90%. In his image, he is currently achieving only 84%. While I understand that increasing the number of modes may help meet the 90% requirement, I would like to understand the significance of achieving this target and how it influences the accuracy of. So, your question, to understand, to explain your question, or if you want to understand your question, you read you read the basics of response spectrum analysis from any textbook, understand what is happening in the response spectrum analysis, and basically the crux of this is that instead of, you are basically combining the results of different mode shapes. Okay, so you are combining the results of different mode shapes with their mass participation and modal deformation criteria. So this modal deformations plus the mass participating in this mode plus the mass participating in this mode, so on and so forth, you are just combining it. And this, when combined, you will get some final behavior of your structure, which you are saying is a combination of all these modes and the respective modal mass participation. So for this modal analysis to be representative means for your modal analysis to show you the appropriate picture of the deformation characteristic of your building, you need to include as many modes as possible so that the total mass participating is at least 90%. So for modal analysis to be representative of the actual response, what your code has decided that please include the number of modes in such a way that at least 90% of mass is participating. Mass percentages lesser than 90% would mean that whatever equivalent or whatever final response you are getting, it's not representing the appropriate or correct behavior of your structure, because you are missing out on some modes and you are missing out on some masses that will get excited in higher modes. So that's why this 90% uh, criteria has been provided by the code. Okay. Okay. So this was his question, and I think we have answered all the questions that were put on the Google form. There is no question on the email. So, no, there is another question that has been asked on the Google form by engineer Sanjay Kumar. He is from Jhanjarpur. I don't know which state is this. Where is this Jhanjarpur? Which state? If you are live in the audience, please type a live. Please type in the comment. Which state is Jhanjarpur in? Okay, so I think he's not in the live audience. So engineer Sanjay Kumar is asking Bihar. Okay, I didn't know where to which near to which big city or town it is. Near to which bigger city or town this place of Jhanjarpur is. Okay, so in the meantime he's answering. Let's see what. Acha, it's near to Madhubani. Very good. Thank you. So how to design C-type shear wall using white column concept in E-tabs. What is white column concept? I don't know what is white column concept. I don't know. But if you want to design C-type shear wall, you just model your C-type shear wall, whatever is the geometry you are finalizing. Just model your shear wall in plan like this, and uh, give separate pier labels to it. So to all these three legs, you give separate pier labels and then run your analysis. When you give separate pier labels, then you will get three different percentages of the wall. Okay, so you will get different percentages. Now it will be up to you to decide whether you want to provide different percentages in three different legs of the wall, like in this leg P1, or in this leg 1 you want to provide PT1 percentage, and in this leg 2 you want to provide PT2 percentage, and so on. So whether you want to do this or you want to just go on with the highest percentage and provide it throughout in your C-shaped wall, that decision you have to take. But otherwise the analysis design process of any shape of shear wall will remain the same as it would be for any rectangular type of geometry. Okay, so nothing changes, but just remember to Assign different peer labels to different legs. Okay. So this was Engineer Sanjay Kumar from Jhanjarpur near Madhubani, Bihar. And now let us take up questions that have been asked on the live comments. So Engineer Magaj is asking, can you please explain column overrides effect like unbraced length ratio, effective length factor one by one? That will be quite time consuming, difficult to conduct or difficult to explain it in a live session like this. If you have any particular doubt, you put your doubt with some supporting sketches. I'll answer them. Engineer Bhavin Patel is asking when to model slab floor elements as membrane, shell thin and thick. So if you just want to maybe not have the out of plane stiffness of your slab, and you just want to have your slab for transferring loads to beam column, you may model it as a membrane. Okay. So when you are not interested in the out of plane stiffness, you just want your slab element to act as a to act as an interface to transfer loads to slab, to beams and columns, then you model it as a membrane. Or suppose you are having some element like a tensile roof or any, what are the other examples that come to my mind? Tensile roof is a good example. So let's say you have a tensile roof type of a system. So that tensile roof does not have any out of plane stiffness, it just has the in plane stiffness. So then you model it as a membrane. Okay. Also, if you ask about the actual slabs, then actual slab like an RCC slab, its behavior is closer to the shell like behavior, because your slabs do exhibit out of plane stiffnesses also. So your actual behavior of slab is closer to a shell like behavior. When to provide thick shell? So when you want in plane shear deformations, or when shear in plane shear deformations are an important criteria for you, then you provide it as a thick shell. Otherwise, for almost all your usual design scenarios, thin shell assignment is sufficient enough. Okay. So thick shell only for very very thick slabs where in plane shear deformations will be important to capture. Then you provide it as a thick shell, not otherwise. Okay. Engineer Harish Acharya is asking, in Stat Pro steel design, if I have load combination defined, Stat is showing dead load as a critical load. How to fix this? You give load list option. Give load list just after perform analysis command. You give the load list command, and in load list you mention the load combination numbers. So suppose load combination numbers are 101 to 120, suppose. So you mention this type of a command after perform analysis. Then stat, what will stat do? Then it will only check your structure for these combinations, not the load cases. Okay. All right. Uh, Engineer Rajesh is asking, he's from Nepal. His question is, in low rise building, reinforcement at upper stories more than the lower columns. So this is the usual problem that you might face, where columns in the upper story, especially for uh, low rise to mid rise structures, column in upper story may give you higher percentages. So this is counterintuitive to what we generally expect, because we expect that as the uh, column load increases as you move towards the footing, the reinforcement percentage should also increase. But this type of a behavior is counterintuitive to our understanding. So why does this happen? Anyone in the live audience? Why do you get, especially in the mid-rise or low-rise structures, why do you get or why does your software, or even in your, when you, if you were to do calculations, why would you get higher reinforcement percentages in upper floors as compared to lower floors? Tell me. Hello. Why do you sometimes see that your reinforcement percentage in the column is greater than at the upper floors as compared to lower floors? Anyone would like to comment? Online Guru is saying, I think he's Anukul. So he's saying moments are higher at top level. See, what happens is that at the upper levels, number one thing, that usually there is only one beam, one column. So the moment distribution factor, if you see, is such that if you compare the moment magnitude with the this joint, you will see that the moments are slightly higher at the top level because of the moment distribution. Okay. So here the moment was to be distributed. The moment from the beam would be distributed to this column above and column below. But at this location roof, the moment from the beam will be distributed only to column below. So number one is moments are higher at the upper level. One of the reasons. Second reason is that actual loads are lower, are lesser at the upper floors. Compared to that, moment is higher, or if I were to say, moment is higher at the upper floor and actual loads are lower at the upper floors as compared to the floors below. So what happens if you, when you go for designing of these columns, if you were in the PM curve at the upper levels, where would you lie? In this zone, I would say in this zone A, or let's say in zone B, or in zone C. Where would you lie in this PM curve of your column at the upper levels? So at the upper levels, you would lie in this zone where the axial loads are also lower. Now, when the axial loads are lower and moment is more or less similar or higher on the upper levels, then what happens? You are in this zone. So when you are in this zone, you can see that the capacity curve or the capacity of your column is lower. So because the capacity of your column, design capacity, is lower under P and M interaction, so because your capacity is lower, you have to provide more reinforcements. Okay, you have to provide more reinforcements. Now compare this with a lower level column, let's say over here. Now it's quite possible that at this level, what's happening, that you are somewhere in this zone. So axial load is in this zone, there is some higher axial load, so you are in this zone of the PM curve. What happens at this level, that you have the highest moment carrying capacity. So because your moment carrying capacity is the highest, a lower reinforcement percentage is also sufficient over here. So this is the reason why you may see this thing in mid to low rise buildings. Now in high rise buildings, what happens, that when you go at the lower floors, because of the very high axial loads, you are again in this region. So again the moment capacity is lesser because of very high axial loads. So because the moment capacity is lesser, again you will see more reinforcement percentages. Understand? So it's an interplay between what is the axial load and what is the moment, which will decide what reinforcement percentages you are getting. Usually for very low axial forces and for very high axial forces, usually you will get higher reinforcement percentages. So these columns at the roof levels in low rise to mid rise buildings are an example of low axial loads with slightly higher moments at the top. That is the reason why you need higher reinforcement percentages. Okay, so I hope this answers this question. So these were the questions that were asked today for this episode on the Google form. So we have answered all the questions asked on the Google form. There was no question on the email, and we have answered the questions in the live chat also. So if there is any other doubt, you may ask, or we will close today's session. Any further question or doubts anyone has? Hello. Okay. So I think there is no more question and no more doubts for this week. So you can continue to paste. Mr. Rajesh is asking beam column capacity ratio. Refer, if you follow the Indian standards, I assume you are asking about the RCC design. You refer IS 13920. I don't know which is the equivalent Nepali code for this. So you refer to 13920 2016. There you will get the calculations for beam column capacity ratio. And this check has to be performed at all levels except for top level up to some height of the structure. I think up to 15 meters you are allowed to exempt your top story from this check, if I remember correctly. Otherwise, you have to perform this check as per 13. So wherever 13920 or wherever ductile design detailing is to be done for your RCC structure, you have to include the beam column capacity ratio check. So you refer this 13920 2016, you will get the procedure, and this ETABS and STAT both are able to do these calculations pretty well. You can also make an Excel sheet uh, automating these calculations. Right. So that's all for this session. We have answered all the queries. So you can continue asking your doubts throughout the week on the same Google form. So Google form link remains the same. I'm just putting it over here in the live chat, and I have also provided, I'm also showing a link to you over here. So throughout the week you can put in your questions. Once every week, typically on a Sunday, we will conduct such a live session to answer your queries. And if you want to connect us, if you want to connect with us on WhatsApp, this is the link. Again, I have put it in the live comments, live chat. So this is the link to connect us over WhatsApp. So I think that's it for this session then. See you next week now. Thank you for joining. Have a good weekend. Bye bye.